I've been hosting Minecraft servers for the past decade, which is a crazy sentence to say out loud, Jesus. When it comes to Minecraft servers, I've learned there are 3 different ways to host one for the public. Option 1, renting a server through game server hosting companies like Apex, Bisect, Shockbyte, or Pebble. Option 2, renting a VPS, or virtual private server, through companies like OVH. Or 3, hosting from home using port forwarding and a free DNS behind a proxy. For the past few years now, for my public-facing servers, I've opted for choice number 1. For my current Minecraft server, xSMP, I've been using Pebblehost specifically due to their relatively inexpensive pricing compared to other hosting companies. However, xSMP is in the midst of transitioning from a single survival server to a full-fledged Minecraft server network with multiple different game types. If I wanted to continue hosting my server through something like Pebble, or even with a more versatile VPS, I'd be spending substantially more money that I quite frankly don't have just in server rent. Pondering my options for a bit, I decided it was time for me to go back to option 3, hosting my Minecraft server from home, but not from my personal computer. Not this time. See, last month was one of the most profitable months that my server had ever seen. In the month of April, xSMP garnered just under $200 from its web store. And by May, there was a little bit over $250 in the server wallet. Not only that, but back in March, I actually switched from my broadband internet provider to a fiber optic provider instead, since one was just made available at my neighborhood, so now I had substantially more upload bandwidth on my home network. With all these factors at play, I began wondering, would I be able to build a dedicated server machine under $250 and just host the thing from my home? And this YouTube video, well, this video is a documentary of that process, but I will tell y'all, it was not an easy journey. When you're dealing with budgets this tight for a project this large, you have to get creative with how you spend such a limited budget on certain components. And spoiler alert, my initial budget was actually $200. I didn't want to spend the other $50, but I ended up having to do it anyways, and we'll go over that later. So we move on to the first step of this process, which was scouring different websites and seeing what components were going for cheap. As a surprise to no one in the PC space, eBay was my savior for this video, and initially I purchased all of the server components through there. For this machine, I envisioned something that would obviously be inexpensive, so I immediately started looking into how much it would cost me to build a first-generation Ryzen machine. As it turned out, it would actually be quite a bit due to the AM4 platform's continued popularity. Even used motherboards on eBay went for nearly full retail price for the same products brand new, which to me is absolutely bananas, but whatever. I was a little bit salty, but I ended up ruling out Ryzen and decided to check out Intel 9th gen products instead, but I actually ended up running into a similar problem with the 9900K being a pretty expensive processor even today. With most listings I saw, if I wanted to buy a 9900K, I would end up blowing my entire budget just on the CPU alone, so that was not an option either. And what I ended up finding was an Intel Xeon E5 2640V4, a 10-core, 20-thread CPU with a boost clock of 3.4 GHz. And this CPU was actually already paired with an X99 Machinist motherboard, and the total for both of these components came out to be $93.51 after tax and shipping. In hindsight, I actually kind of regret this purchase because I found out that the Machinist X99 board can be had for $56 on Amazon, and then the Xeon processor itself is like $8, but whatever, I spent a little bit of extra money for the sake of convenience. Now that I had the CPU and motherboard, it was time to look for a CPU cooler, and what I ended up finding was this very beefy HP Z440 workstation CPU cooler. It uses the 2011 V3 socket, and it ended up costing me $1548 after tax, which for how big this thing is was an absolute steal. After this, my next venture was the RAM, which it turns out is extremely inexpensive when shopping for ECC RAM specifically, which the motherboard allegedly supports. I found a 32GB kit for $1695 after tax, which when compared to the $45 retail price of most desktop 32GB DDR4 kits was also a steal. Now that I had the RAM, it was time to look for an SSD, because this X99 board actually had an M.2 slot on board, which isn't super surprising. After all, machinist boards are Chinese repurposed boards using recycled chipsets, so they can kind of throw whatever they want on there. So I took advantage of this and I started looking around for M.2 NVMe SSDs, and I ended up finding a 512GB NVMe SSD from Dell for $19 after tax. For the graphics card, I literally just needed something that would display out. It didn't need to be anything fancy, so I ended up landing on the R5 240, which can be easily found anywhere around the $10 mark. For the particular card that I bought, I paid $9.22 after tax. Finally, the last part I needed to buy was a power supply, and although I don't usually buy secondhand power supplies, and if you're watching this and you are planning on building a primary system that you're going to use every day, do not buy a secondhand power supply. Please, just don't do it. Buy a new one, spend the extra 20 bucks. Trust me, you're going to find out later in this video that it's worth it. At any rate, I ended up finding an HP 475 watt power supply, used, pulled from a working system for $21.19 after tax. The price was so alluring, I just had to grab it. So now, with all of these parts added to my cart, the total ended up being $175.43 after tax and shipping. Well under the initial $200 budget I had set for myself. The only thing to do was to click the place order button and wait for each individual component to arrive at my house one by one. Once all the parts arrived, I immediately assembled the computer and shorted the power switch pins on the front panel header of the motherboard with excitement. But unfortunately, all I got was an audible click from the power supply and a split second of fans spinning. This is a telltale sign of an insufficient power supply. I didn't realize that the 12-volt rail would not be enough for this build, and unfortunately I could not move forward with the power supply I had purchased. To remedy the situation as quickly as possible, I went to Best Buy and I found a 700 watt Thermaltake Smart power supply for $54.99 or $58 after tax. There was also a 500 watt version of the same power supply, but it was $49.99, so I figured for the extra $5 I might as well get the 700 watter. So that's what I did. I placed my in-store pickup order, picked up the power supply, went home, swapped it with the old one, and I turned the computer on to the fans actually spinning. The computer had successfully turned on, which I was very happy about, so I started spamming my delete key in anticipation. But unfortunately, the machine would not post. There was something else wrong. But hey, it's cool. I have IT experience. I followed all of the basic troubleshooting 101 steps, reseated all the power connectors, reseated the DIMMs, reseated the M.2 drive, and even at one point I reseated the power supply. But unfortunately, with each attempt I did, nothing worked. The computer still would not post. After I reseated everything I could think of, I began the part swapping phase of the troubleshooting process. The first thing I did, because it was the easiest, was changing out the RAM from the existing kit that I had bought to a kit that I already had in my personal machine that I knew worked. Funnily enough, this was the only part that I ended up having to swap, because my computer's RAM ended up working beautifully with the server, and it actually posted. Once it did, I immediately went into the BIOS to check out the memory configuration to make sure that the server could support RDIMMs, and it could, and it was set to be compatible with anything, whether it was regular UDIMMs or RDIMMs or just standard desktop DIMMs. So as a final Hail Mary, I decided to change the DIMM configuration to RDIMM only, saved my changes, turned the computer off, put the original server DIMMs back into the machine, and tried booting it up again, but unfortunately, once again, no post. And the sad thing is here, I can't pinpoint exactly what's happening because there are three possibilities. Either this machinist board that I got just doesn't accept RDIMMs at all, the brand of RDIMMs that I bought just aren't compatible with this board, or the RDIMMs that I purchased are just DOA. And since I don't have any other motherboards laying around that take ECC memory, I have no way of testing any of my theories to figure this out for sure. Regardless of why it was happening though, even knowing the answer wouldn't change the fact that I can't use these RDIMMs. So I put my personal 16 gig kit back into this computer, cleared the CMOS, and I ended up buying a new 32 gigabyte RAM kit from eBay, this time opting for a consumer grade kit than risking another set of RDIMMs, which funnily enough ended up costing me more money, and this was in an auction. But as of the making of this video, I do not have that kit on hand, so for all intents and purposes for this video, this server is going to have 16 gigs of RAM for now, which unfortunately means that my personal computer will also only have 16 gigs of RAM now, which kind of sucks, but whatever. But okay, we have a working computer now, the troubleshooting is done, so what's next? Well, for me, I disassembled the entire computer and laid out all of the components on my desk so you guys could watch me put it all together one last time. Since I did all the troubleshooting off camera, I figured it was only fair that I at least give you guys some footage, so I figured that assembly footage would probably be the best here. So here's me putting the computer together. The pinkish substance that you're seeing under the motherboard is pink anti-static foam. In lieu of putting the server in a case or on a test bench, this was my next best option. And as I mentioned before, look at how beefy that CPU cooler is. This thing is freaking huge for $15. And in the heat of the moment, of course, I ended up forgetting that the M.2 slot is underneath where the CPU cooler goes, and I had already installed the CPU cooler. So what you're looking at now is me fumbling around with the M.2 SSD, trying to get it to fit into the slot. Thankfully, I was able to eventually get it in there, so we're all good. And since this R5 is a very low wattage card, no extra PCIe connectors are required, this thing just sips on the motherboard power instead. And of course this power supply isn't modular, so I'm gonna have to find an elegant solution for all of this cable vomit. Okay, now that the computer is completely assembled, I am going to relocate it to a part of my desk that my kids barely know exists. Until I get a test bench or an enclosure for this computer, I'm just going to hide it under here because 1, it helps me hide the cable vomit from the power supply, and 2, my kids probably won't touch it. Alright, now that everything's plugged in, let's turn this bad boy on. And we successfully have a display. Awesome. So now here's a time lapse of me just letting the Windows installer do its thing. It honestly actually didn't even take that long. It's pretty crazy how fast even the slower M.2 SSDs are. And just like that, now we're at the startup screen for Windows. For your guys' sake, I'm going to speed through this too, but all you need to know is I turned off all of the default Microsoft things that it asks you to enroll in, like advertising ID and things like that. I used an offline account, and I disabled Cortana because Cortana doesn't even exist anymore. I don't even know why that's still a thing. I guess because it's Windows 10, but still. And just like that, we are now at our desktop. Now, in the time between this transition from camera to screen capture, I actually ended up doing a bunch of cleanup work. I uninstalled basically everything that Windows pre-installs for you, so this computer is running on bare bones at this point. I did install a couple of necessary programs for me, like Firefox, 7-Zip, and HelpWire, but otherwise this thing is completely clean. Looking at the task manager, we're bouncing between 1 to 2% CPU usage, and less than 3 gigs of RAM being used. But okay, now that I have a fully functioning computer with Windows installed and activated, before I do anything else, I need to run some benchmarks to look at how well the hardware is holding up. Looking at the Cinebench score here for the CPU, it looks like the Xeon is sitting in between the Apple M1 and the 12th gen Intel Core i7 1280p. For an $8 processor, honestly, I'll fucking take it. This is pretty good. My next benchmark was Furmark, and naturally, there are no results to write home about. Though notably, the R5 240 is faster than the GT 710 from Nvidia, so I guess that's something. But yeah, the GPU temperature capped out at 57 degrees. It's staying cool. Everything's fine here. Moving along to Crystal Diskmark, I am actually kind of surprised with these results. I was expecting less read speeds, but it does concern me too, because the read speeds being 2100 megabytes and then the write speeds being only 1100 megabytes, that tells me that there is probably some degradation. So I downloaded Crystal Disk Info and pulled it up, and surely enough, while it's technically still in good health, this SSD has been put through its paces. Nearly 20,000 hours of power on time, 65 terabytes worth of reads and 67.5 terabytes worth of writes, brought this thing's health down to 57%. I'm a little upset about it, if I'm being completely honest, but ultimately it shouldn't have any issues. Sure, it's definitely running a little bit slower than it was in its prime, but otherwise there's not really any sort of warning signs here that I have to look out for. But okay, so the CPU is good, the GPU is running as expected, and the SSD, while a little bit rough, is in working condition. In fact, as a side note here, I will say, a layman would have a very difficult time being able to tell that this computer was a handyman special. Like, this computer takes less than 10 seconds to boot, the OS is insanely snappy, and CPU-intensive tasks like unzipping files is a breeze for this processor, which is 9 years old. While it certainly doesn't hold a candle to my 5700X3D, this thing it's respectable, especially for its age. I'm very impressed with this computer. But okay, now that we've assembled the computer, we installed Windows, we tested everything, everything's good, it is now time to work on all the prerequisites involved with hosting a Minecraft server from home. Just a little warning for my non-networking viewers, things are going to get progressively more complicated from here. While I do my best to explain in clear English what I'm doing, I know that there will be some non-techie viewers watching this that will probably get lost in the sauce with all the tech jargon and acronyms I'll be using. To you guys, I sincerely, deeply apologize, but I promise I'm going to do my best. So the first thing that I have to do, which you should do with any Minecraft server, is purchase a domain, which I already did. It's playxmc.us. It was simple enough and very cheap through GoDaddy. Speaking of GoDaddy, now that I've purchased a domain, I'm actually going to ditch them at this point. At least when it comes to handling the DNS records, I am going to change the name server from GoDaddy's own to Cloudflare. Why am I doing this? Well, because Cloudflare has a free proxy service. This server is being hosted from my home, and that means that if I don't have it behind a proxy, people will be able to dump the DNS and see my home network's public IP address, which I do not want. There are other better alternatives out there that usually involve paying a monthly subscription for a VPS, but since Cloudflare provides this service for free, I didn't feel like paying for anything extra, so this is the route I decided to take. Now that everything's transferred over to Cloudflare, I'm going to go ahead and create a new record for my DNS. This is going to be a type A record, and it's just going to be my IP address from my home, which I was able to get by going to ipchicken.com. Naturally, I'm not going to display what my public IP is, because that's the very thing I'm trying to hide, but all you need to know is that the type A record, it's being routed to my personal IP address from home, and the name is playxmc.us. And then the most important step in this whole process, and the whole reason I changed to Cloudflare in the first place, is because I'm going to enable this proxy. After I did this, I was checking DNS Dumpster periodically, and for a little bit it kept coming up with my home network's IP address and all of the stuff relating to my ISP and everything. But after about an hour and a half, everything changed over from all of my home network stuff to Cloudflare, and now everything is Cloudflare. While this isn't a foolproof solution, I mean, arguably nothing is, when it comes to cyber criminals targeting Minecraft servers, unless it's a very large server, it's usually script kiddies. Teens, tweens, and young adults with intermediate cyber knowledge at best, so this will probably be enough to stop them, and that's really all I care about. Any expert cyber criminal out there that is so determined to take my server down that they're willing to exploits in Cloudflare services, honestly, at that point I would just come to the conclusion that they have way too much time on their hands. But okay, now that the server's domain is behind a proxy, my next step is to grab my server machine's local IP address, which can be done by going to the command prompt and typing in ipconfig/all. From here, I'll find the IPv4 address, which is the address that your DHCP server within your router assigns devices. And now that I know what IP address this machine is, I'm going to go into my router settings and actually make sure that the DHCP server assigns this machine this local IP address every time. This is an important step because if I don't do this and the server reboots, there is a small but still a possibility that the server will be assigned a different local IP address, and then all of the port configuration that I'm going to have to do is going to get messed up. Speaking of port configuration, that's actually my next step. So I'm going to go into my Eero app, and I'm going to open the ports for this IP address for this device, and I'm going to open the ports 25565 to 25568, as well as 19132. 25565 is Minecraft Java's default port, and since this is going to be a server hub, all the way up to 25568 are going to be the ports for the other servers in between. As for the 19132 port, that is Minecraft Bedrock Edition's default port, and since my server is going to be Bedrock compatible, I'm going to need that port opened as well. But alright, now that the port forwarding is done, that's really it. All the prerequisite stuff is done. I got the DNS, added my home IP address to its records, put it all behind Cloudflare's proxy, ensured my server machine will have a static local IP, and opened all the necessary ports that I needed. Now it's time to actually get to the Minecraft portion of this adventure. The first thing I have to do is download Adoptium. This is a necessary Java runtime library to host the servers from this computer. Without it, nothing Spigot or Paper or anything doing Java will work. Thankfully, installation is easy, took me a few minutes, and now it's already installed. My next quick step is to go to Windows Explorer and enable the ability to view file extensions, which will be important for making batch files. After this, I'll create a folder where all the server directories will go. This folder is going straight on the desktop, and within this folder, I'll need to create folders for all the different servers that I plan to host. The first server, which will be the forked bungee cord proxy that ties all the servers together, will be named after its port for the sake of organization, 25565 Waterfall. I'll preemptively create the folders for 25566, 25567, and 25568 as well. In order to actually create the bungee cord proxy server, I have to download Waterfall from PaperMC's website. I really did want to use Velocity since Waterfall recently reached end-of-life status, but unfortunately there are certain plugins that I need which are incompatible with Velocity, and there are no comparable alternatives out there that work with Velocity right now, so I had to resort to using Waterfall instead. That said, now that I've got Waterfall downloaded, I'm going to drop it into the 25565 folder and create a notepad document. Immediately, I'm going to rename the document to run.bat, and this is going to convert the file from a txt file to a bat file, an executable. From here, I'll right-click the file and edit it, which opens Notepad anyways. In Notepad, I'm going to write the necessary Java command to initialize the server. I'll be assigning this server 512 megabytes of RAM since this is just a proxy server, and the name of the necessary jar file the server will be executing off of. After this, I'll Shift+Enter and add the pause command. Now that I've done this, I'll save my changes and execute the run.bat file. Immediately a command prompt window opens up, and now the Waterfall server is generating all of the files and folders necessary for the server to run. I will have to configure a lot of this stuff later. Now that all the files are generated, I'm going to execute the end command for the server to stop it, and I will come back to the Waterfall server configuration later. Since Waterfall involves tying all the servers together, I need servers to tie together in order to configure it, so I'm going to work on the other servers next. Thankfully, I already have two of the servers ready to go, my survival server and the server for the lobby. All I have to do is transfer the files from my personal computer over to the server computer, which I can do directly through my LAN. The lobby server will take the port of 25566, and the survival server will take the port of 25567. But I do have to create the creative server, which I haven't done yet. So for 25568, I'm going to be making the creative server from scratch. To do this, I'll download the latest version of Paper 1.21.5 from PaperMC's website. Now that I have the paper jar file, I'll just click and drag it right into the 25568 folder. Then, from the 25565 folder, I'm just going to copy the bat file that I already created, and I'm just going to paste it right into the 25568 folder. Then I'll modify the bat file to change the RAM to 2 gigabytes for now, Once I do this, I'll just run the bat file and it will immediately open the command prompt again, but then it immediately stops because I have to accept Microsoft's EULA. So I'll open the EULA file, set the toggle to true, save it, close it, and then rerun the bat file. And now, as we can see in real time, all of the files and folders are generating as they should, and the server is creating itself. Just like that, I now have a bunch of servers in a folder that don't technically work yet. See, all the files are generated for these servers, but now we actually have to go through config in order for these servers to be assigned the right IP address, the right port, and that they're all connected through waterfall. So the first thing I'm going to do is open the server.properties file in each respective server, except for the waterfall server, which doesn't have this file. And the first thing I'm going to do is set the server IP using the local IPv4 address I grabbed earlier. The next thing I have to do, since all of these servers are going to be connected through waterfall, is set online mode to false. Online mode basically requires the client that's connecting to do a handshake with Mojang servers every time that they connect, but if they're connecting through a proxy like waterfall and they go to try to connect to another server that's in online mode, it will actually cause them to not be able to connect, which is what makes this step very necessary. Now I'm going to change the server port for each of the servers in the server.properties file, but each server has a different port. So for the lobby, we're going to set that to 25566. For survival, we're going to set it to 25567, and for creative, we will set it to 25568. Now that I've done that, I can save my changes to all of these files. And now for each server, we're going to open the spigot.yml file, and we're going to set the bungee cord configuration from false to true. After this, we'll save our changes for all of the files, close them down, and now these servers are prepped and ready to be attached to the waterfall proxy. So now I'll navigate to the 25565 folder and open the config.yml file. From here, we'll ensure that online mode is set to true, which it is, and now under servers, we're going to delete what exists, and now we're going to assign specific servers. The first server will be the lobby. The MOTD doesn't really matter, but I'm going to just throw something in here for the fun of it. The IP address is just my server machine's local IP address, :25566. And for the restricted toggle, we'll leave that at false. Now I'll just copy the format for the lobby server and do the same thing for survival, except I'll be changing the port to 25567. And again with creative, setting the port to 25568. And now the last thing I'm going to change is the forced hosts. We're going to set the forced host to the lobby. By doing this, whenever a player joins the server from the IP address, they will be instantly shot to the lobby, regardless of what server they were on previously. Whether they were playing on survival or creative, or if they were already in the lobby, whenever they leave the server and rejoin it, they will always join back in the lobby. And now that all of this is configured, I can save my changes, close this out, and now if I open all of the servers, we should see them all turn on and connect to each other properly. In order to test this, I'm going to open my Minecraft Java client on my personal computer and try to connect through the IP address playxmc.us. And surely enough, there is the server, and if I join, I am now in the lobby. And if I do /server creative, I am now on the creative server, and if I execute /server lobby, I will be sent back to the lobby. Everything is connected just as it should be. Now that I know that everything is working exactly as it should be, there's really only one more thing for me to do. I'm going to create shortcuts for all of the run.bat files for all of the servers. Once I have all of these shortcuts on my desktop, I will hit Windows R and type in shell:startup. This is the Windows Startup folder, and now I'm just going to click and drag all of these shortcuts into this folder. So now if I restart the server machine, or if it ever powers off and powers back on at any time, as soon as Windows loads up, it will immediately launch all of these servers. This way, if for whatever reason I need to reboot the computer, I won't have to go through and turn every single server back on manually. It'll just do it all for me. But yeah, everything now is completely done at this point, and I'm free from having to pay server rent ever again, which is just a beautiful thing. At this point, all I have to do is plug in configuration, but if I recorded that process, we'd be here for hours, and quite honestly, that's proprietary information anyways, so I'll keep that to myself. Thank you very much. Now, just putting this endnote here so you guys know, I only went this route because I needed a high core count and high RAM capacity to handle all of the servers I planned to host at once. For my niche case of having all these multiple servers running on one machine, it was just simply cheaper for me to build the computer myself rather than buying something that was already pre-assembled. That said, if you're a prospective Minecraft server owner looking to host your own singular Minecraft server without renting, there are plenty of options for you that are much less expensive than what I did. After scouring Amazon for a grand total of 10 seconds, I ended up finding this computer that has an Intel Core i5-6500, 8 gigs of RAM, a 256 gig SSD, and an activated copy of Windows 10 Pro, and it's $96. And the best part is, it's pre-assembled, and it has Windows already installed. You don't have to do anything. For someone hosting a small Minecraft server with about 4 gigs of RAM assigned to it, this machine is literally perfect for that. And if you need more storage or more RAM or whatever, there are comparable models with the same Skylake architecture processors that are around the $120 to $150 price range. But yeah, for my use case with multiple servers and everything and all the RAM that I'm going to need just for the survival server alone, this machine was not going to cut it for me, and that's why I took the route that I did. That being said, guys, I really hope those of you that stuck it here to the end really enjoyed this video. This was a massive project for me, and I'm just glad it turned out to be a success, even if there were a few hiccups with the server hardware along the way. Building computers and doing networking stuff in general is something I really enjoy doing, and Minecraft is one of my favorite games of all time, so I'm happy to have been able to share this entire experience with you all. I really hope you guys found this video to be a nice blend between informative and entertaining, especially those of you that are potentially looking to start your own Minecraft server adventure. Thank you all for watching. My name is Brendan, this is BearBear, and for all my fellow humans in the Northern Hemisphere, enjoy the rest of your spring. Take care, guys.